Okay, welcome back. We'll continue from where we stopped in the last video, talking about the DL of 1 plus x raised to the power of alpha, and this is the DL. And I said we can use this formula to get other DLs from this same perspective. If, like for example, the DL of square root of 1 plus x can be gotten, this is the same thing as 1 plus x raised to the power of 1 over 2. So all you do is you make alpha to be equal to 1 over 2. And if alpha is equal to 1 over 2, you just place it here and you get the DL of square root of 1 plus x. So let's do that. I replace this with 1 over 2. Okay, I replace this as well with 1 over 2. I replace this with 1 over 2 and this with 1 over 2. Now, if I do that, I'll be getting, this is 1 plus 1 over 2x, right? Plus 1 over 2 minus 1 is minus 1 over 2. So we're subtracting this is minus 1 over 2. And minus 1 over 2 times 1 over 2 is minus 1 over 4. And minus 1 over 4 over 2 factorial. So this becomes minus 1 over 4 over 2 factorial. That's this 4 automatically comes down here, so this becomes 1 over 4 times 2 factorial, and 2 factorial is 2 times 1, so it's basically 2, so this is times 2, and so that will be 1 times 4 times 2, which will give you 8. So this will be a minus, and we'll be having 1 over 8 x raised to the power of 2 plus x squared epsilon of x. So that's how it is. Like for the other odd, we are giving odd 3, 4, 5, 6. You just keep putting in the values there, and then it will be your DL. Just by using 1 plus x raised to the power of alpha, you can get it. Now, I should put back my alpha. Okay, so that's for this. Then alpha x plus alpha minus 1. And they might be thinking, like, what about if I want to go to order of 3 using 1 plus x raised to the power of alpha? I just make a note here. You just continue the same way. Alpha minus 2 x raised to the power of 3 over 3 factorial. If I want to go to order of 4, this becomes alpha minus 3 x raised to the power of 3 x to the power of 4, and this changes to 4 factorial as well. Yeah, so that's how it is. So if we are to take the order of square root of 1 plus x to the order of 4, we put in this formula, we put them inside. But there are still some times where your professor would actually tell you to calculate the DL and not to find, like, not just to find it. This is just for you when you're answering other questions where you see, like composite, for example, where you see that the two functions you have to use another function to get the final answer, and you happen to have this function there. You don't have to recalculate the DL of that. I mean, you already know what it is, so you apply. That's where this comes in. But if your professor should actually tell you calculate the DL of sinus x or the DL of cosinus x and log 4, for example, voisinage de 0, you go back and use your Maclaurin. It's pretty easier that way. You just keep deriving sinus x up until the order of 4, and then you put in your 0 and then place it back in your formula, and that's it. So same with cos and same with that. So, but if you are just trying to randomly get through a question and you just want to quickly put in, okay, I know that just like I know sinus A plus sinus B is this, I don't have to derive how sinus A plus sinus B. Yeah, that's basically why we're doing this. So remember, we're going to the order of 2, so that's for the square. That was for the square root of 1 plus x. Now if I'm given 1 over 1 plus x, I know in the previous video we already calculated the DL of that. That's exactly what I'm talking about. There's sometimes we have to calculate DL. In this case, we've already calculated it, we know what it is. But how about just trying to derive it from 1 plus x raised to the power of alpha? We know this is the same thing as 1 plus x raised to the power of minus 1. And same thing, all we do is replace alpha with minus 1 and we'll get the DL for 1 over 1 plus x. We'll do that. So I replace this with minus 1. So this would be a negative 1. Here I'll have a negative 1. Here I'll have negative 1 as well. Remember there's a negative here before. So if I have that, this would be okay. This, it will become a minus because it's plus and minus, so I'm going to have minus x. Here minus 1 is minus 2, minus 2 minus 1, that's minus 3, right? Minus 2 times minus 1, I'm sorry, we have minus 1, I think it's because, yeah, so this is minus 2 and this is minus 1, so that's 2 because minus 1 times that's 2. So this entire would be 2 x, and 2 factorial is 2, so it will automatically cancel, so you're left with x squared plus x squared exponential x. Now the thing here is just like if you notice the signs are also alternating. Yeah, that's how the DL of 1 plus x raised to the power of minus 1 or 1 over 1 plus x is. So it will keep alternating. You know, we have 1 minus x plus x squared. The next one will be minus x raised to the power of 3, then plus x raised to the power of 4. It keeps alternating. The odd numbers, the odd degrees will take the negative, the positive degrees will take the positive. So that's how to get the DL using that part as well. Then finally, I just want to make a little change from how we calculate the DL, just one special case, but it also works for this. Alternate it or use Maclaurin formula, what I'm about to do. So there are various ways you can actually go about it. Just depends on the one you feel will be easier for you. I'll be using the sum of a geometric sequence to find the DL of 1 over 1 minus x. Oh, I think my black is marker, so I'll be using the red for now. So to find the DL of 1 over 1 minus x, we can find it either by Maclaurin, or you can find it by using the sum of geometric sequence, which is another method. I know generally the formula for a geometric sequence. The general formula is this. Which is equal to 1 minus x raised to the power of n plus 1 over 1 minus x. This is the general formula for a geometric sequence. Alright, so we can use this to find our DL of 1 over 1 plus minus x. I know that this is the same thing as 1 over 1 minus x because it's a subtraction and it has the same denominator, so I can have this. Okay? And this is going to, like, we're looking for the DL. I'm trying to look for it to actually prove to you that this is actually the DL of 1 over 1 plus minus x. It's just 1 plus x squared plus x cubed, x raised to the power of 3 plus x raised to the power of 4 up to x raised to the power of n. So this is also where I'll show us exactly what our epsilon of x is all about. We just proved here that 1 over 1 minus x, this is the DL for it. So whatever we have after that is basically our rest, is basically our epsilon of x, or our petito x raised to the power of n. This is our rest, because we just need the 1 over 1 minus x, right? So this is basically our epsilon of x. Yeah, x raised to the power of n, epsilon of x. So the DL of 1 over 1 minus x is just 1 plus x squared plus up to x raised to the power of n. So time for our exercises. Don't mind me. Time for exercises, and then I'll see you in the next video. Don't forget to subscribe and share with your friends so they can also benefit.